So we're going to look at reduction to linear form now using the method of least squares. If we have a nonlinear equation, it's sometimes possible to transform it to a linear one. That's what it says here, of this form. And then we can read off fit the straight line, can't we? The m value and the c value using the method of least squares once we've got a straight line. So here's some examples here. If you have something y equals ax squared plus b, and you're given this as the property, then you can see that if you take x to be, capital X to be x squared, you're going to have y equals ax plus b, y equals mx plus c, in other words. That's a straight line. So by plotting these values against y in this particular example, we'll get something, data that resembles a straight line that we can fit, and then we can work out using these squares the approximate values for a and b as far as the best fit is concerned. Here, just 1 over x, that's a lots of 1 over x, isn't it? So you can see y would equal the m capital X plus b. Again, this one, take logs both sides. Log of this is times you add log a plus that. The power comes down, so you get n log x plus log a. Y equals m x plus a value, a constant. There we are. So if we plot y against log y rather, against log x, then we'll work out the gradient n, and we'll be able to work out the intercept, which will be log a, and from the intercept value of log a we'll be able to work out the value of a that fits the curve according to least squares curve fit. This one, if we take logs, it brings everything down to ground level. Log of this is log times you add, and then the bx comes down to ground level. Log e is 1, so it's just bx plus log a. So there's your y, and there's your b. M x is your normal value of x plus log a. Your intercept is log a. Once you know that value on the line, you can work out the value of a as far as the best least squares curve fit is concerned. This one, take logs again because it's in the power. That'll bring it down to ground level. Log is log a plus log of b of x log b. So we've got log y is m x, because the x comes down to ground level, plus log a. So our gradient would be log b, so we could get b from the gradient then. And our intercept is log a, and then we could work out a, according to the least squares curve fit. So without further ado then, let's look at an example. We'll do a couple of examples here. So let's take logs. We've got the data and we want to try and see if we can reduce this to linear form. So let's take logs. Log s is equal to times you add, so it's ln e to the b times t. And so we've got ln s is equal to, the bt comes down, log e is 1, so it's bt plus ln a, isn't it? Here's our curve, so y is equal to m x plus c. Okay, so that's good. So now we got our data, and we can do our least squares curve fit now. We need to plot t, so let's keep the t values. 2, 3, 4. And then we need to plot log s. So we've got s and we need ln s, don't we? Log of s, so I'll just tap those out. 2.34. Well, I'm just going to put them in as ln 2.34 actually for the time being, because it keeps the accuracy. This is ln 2.75. This is ln 3.16, ln 3.63, ln 4.16, and we're keeping accuracy by doing this. ln 4.79 and ln 5.62. We're not rounding at all. We can round at the end, hopefully, if it's not too onerous to do. Otherwise, if it was too onerous, we just work these out to say 3 or 4 dp. Okay, there's our x then, so to speak. There's our y. So in our customary table then, we need the product xy's, which is 2 times ln 2.34, 3 times ln 2.75. And I'm going to tap these in the calculator. 6.3. Hopefully it won't take too long. And then 7 times ln 4.79, and then 8 times ln 5.62, and then we need to do xi squareds, don't we? We need that one. So let's do those. Okay, so 2 squared is 4, 9, 16, these are okay, 25, 36, this squared is 49, and 8 squared is 64. So now we need to work out the totals when we add them. Okay, good. So the total of that, the total of this, and the total of this is what we need. And then we can work out x bar. So let's do that. So ln 2.34 2.75 ln 3.16 ln 3.63 4.16 4.79 5.62 close bracket. 9.01, so I'm going to go back and check everything's okay. Yeah, I think it's okay, because I think that should be alright. So 9.0199, so I'm going to keep it nice and accurate, so I'll write 9.0199, 9.0199, so that's good enough, accuracy wise I would hope. Now this one, I'm just going to toggle back hopefully, and rather than type it all in, and just put the multiples on in the expression. So 2 times this one, 3 times this one, 4 times this one, 5 times this one, 6 times that one, 7 times that one, and lastly, hopefully there's one more, 8 times that one. Yeah, equals 49.1130. 49.1130. Yeah. And then sum these. Okay, well I'll just tap that in. 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64. 203. Okay, now we need x bar, and we need y bar, don't we? Also, x bar, sum the x's, divide by the numbers. Sum of the x's, 5, 9, 14, 20, and 15 is 35. So that's 35 over 1, 2, 3, 4, 5, 6, 7, which is 5. And y bar is sum of the y's, 9.0199, divided by 7. 9.0199 divided by 7 equals 1.28855. 1.2885, and that was a 6, I think, if I round it. Yeah, 5.6. Okay, good. So now we need our formula, and we'll work out M and C now. So here's the values. So let's just get them. And we'll drag them down. So these are the formulas we need for the M and C values, so to speak. Oops. Well, I'm going to have to move something, I think. I'll try and... No, I'm going to have a job here. So let's just let's just move something now. So I'm going to get rid of this. I'll get rid of my original data so I can move everything up. In the problem, I'll just scratch this line here. There we are. And then I'll do an edit paste. I'll move this stuff up slightly. I think I've made a mess above anyway, so let's just get rid of that. Okay, good. So we've got our values. Oh, I don't need our table values anyway now, do I? So we can actually scratch those, all those, can't we? They can be scratched. Well, I'll leave them in situ, sorry. I'll get myself sorted now. So let's move this up then. There we are. Just move that up there slightly. That should give us enough room to work with now. Okay, good. That's what we've got. So edit paste then. And then we'll drag it down. Let's move it down then. And then we'll work out these values. There we are. Okay, good. So our m value, y equals, remember, mx plus c. So m is b. So I'll put that in straight away. That's b. And the c value, which we'll put in straight away, is mx plus c, is log a. So this is the value for log a, isn't it? The intercept value. So be careful there. Summation of x, y's then, put the numbers in. 49.13113. minus n was 7. X bar, y bar, so that's times 5 times this number here, 1.28856, over the summation of the x squared, 203. Minus 7 times x bar squared. Minus 7 times x bar squared, 5 squared. Okay, so b equals then top number 49.113 minus 7 5s are 35s times 1.28856. Top number divided by bottom number 203 minus 7 times 5 squared is 25. Cause 0.143 then, and that was to 3 decimal places rounded at the end, and ln a is equal to y bar 1.28856 minus m, which is b, which we've got in the calculator, times x bar, and x bar is 5. So ln a is equal to, so this number, sorry, 1.28856, 1.28856 minus the number, ants b, times 5, wasn't it, for x bar? 0.5718. So a is e to this number, so shift e of answer equals 1.7715, so 1.772, and that's to 3D rounded at the end. Okay, there's a and b. So remember what we had at the beginning, s is equal to a e to the bt